So let's just go ahead and state the quotient rule. We could work out the proof of it. It exists out there. I'll tell you it works very similar in terms of the concept when we did the proof of the product rule back in topic 2.8. But it does get a little bit messy algebraically because you're talking about a quotient of functions. But what the quotient rule says is if I want to take the derivative of a function that is expressed as a quotient of two functions, in other words, f of x over g of x. And it equals, and this may look kind of nasty, I'll give you a little bit of a mnemonic to try to remember it at the end. What it equals is, in the numerator, you're going to have g of x times f prime of x minus f of x times g prime of x, and it's going to be all over g of x quantity squared. Now, a couple of things happen here that maybe look a little bit like the product rule. You might see the numerator and say that looks a little bit like the product rule. With the product rule, the ordering of the functions didn't matter. The same way that the order of multiplication doesn't matter, the product rule had an addition sign. And so the ordering of them did not matter. In division, the order matters, and the same is going to be true up here in the numerator. It has to be in this order, where it's the denominator, the function in the denominator, times the derivative of the numerator, minus the numerator, times the derivative of the denominator, and it's all over the denominator, whatever that quantity is, being squared. Now then, there's a little bit of a mnemonic or an idea to help you kind of memorize this, if you will, because we do need to know our derivative rules really to move forward in this class. So the quotient rule can be remembered. This is the phrase I always give. And it's a little bit cheeky, but it does help you remember it. In fact, I oftentimes will hum it to myself just to make sure I get the ordering right, because the order matters here with the quotient rule. So it can be remembered with the phrase. And I'll walk you through what this phrase kind of represents. But the phrase that was taught to me, and the phrase that I'll teach to my students, is low d high as one expression. So low d high minus high d low, all one expression there, over low squared. Now then, if you can tell already by looking at this, the low and the high represent the numerator and the denominator. The high representing the numerator because that's the high part of the fraction, low representing the denominator, the bottom part of the fraction. What the d represents is that's what you take the derivative of. So when it says low d high, that means low, g of x, times the derivative of f, and that's what you have here, minus high, which is f of x, d low, the derivative of g, which is what you have, all over low squared, or the denominator squared. So if you think to yourself low d high minus high d low over low squared, it gives you an idea of how the quotient rule will work, and it gives you kind of an easier way to memorize it than just trying to remember this particular expression right here. But this is the quotient rule, and if you want to see a proof of it, I would encourage you to do so because it works pretty similar to the proof that we did in this class of the product rule back in topic 2.8.